Hello. In this problem, we have a triangle ABC. The side length BC is congruent to DC, congruent to AE. So points E and D are selected in a way that we have these congruences. The angles at B and C are both 80 degrees. And the question is, what is the angle BED? So find the degree measure of BED. So we'll go ahead and draw a line parallel to BC through D. Call the intersection of that line with the side AC, AABF. Also draw a parallel line through E with the line BC. And call the intersection of that line with the side AC, point G. Also, we go ahead and construct an equilateral triangle based on the side BC. So this triangle HBC, we are assuming here that it is equilateral. And therefore, these angles are 60 degrees, both of these. The angle HBC and HCB are both 60 degrees. Now connect point H to D. And to F, and to E. Now first look at the triangles AEG and triangle HCD. I claim that these two are congruent. The reason is that, recall that the side CD is congruent to side AE. So we have CD congruent to AE. And side HC is congruent to BC. That was by construction of this equilateral triangle. But BC was made to be congruent to CD. So this is an isosceles triangle. Since this line was parallel, this is also an isosceles triangle. This angle here is 20 degrees. This angle is also 20 because this entire angle was 80. 60 of it is coming from this equilateral triangle. The remaining would be 20 degrees here. And so angles A and angle C are both 20 degrees. So these two triangles are congruent by side angle side. And a conclusion of that will be that the side EG is congruent to side HD. Now, moreover, we notice that this angle here is congruent to this angle here. So we're going to focus on the quadrilateral EGDH. In this quadrilateral, we see that angle G is congruent to angle D. So to see that, well, first notice that this angle is, well, this was 80, so this would be 100 degrees. This is 100 degrees. I want to show that this is also 100 degrees. Well, this part of it is 80 degrees because this line was parallel. This angle is corresponding to this angle. This is 80, therefore this is 80. I claim that this angle is 20 degrees. So that 20 plus 80 will be 100, will be congruent to that. So, well, to see that, we notice that this angle here is 80 degrees. The angle FDC is 100 degrees, and so this angle will be 20 degrees. So the angle FDH is 20 degrees. And therefore the angle GDH will be equal to the angle GDF plus the angle FDH equals 80 plus 20 equals 100 degrees. So we show that these two angles that are marked here, the angle EGD and GDH, are both 100 degrees. So in this quadrilateral now, we have the following situation. We have side EG congruent to side HD, and angle G congruent to angle D. That's sufficient to show that GD is parallel to EH. So line GD is parallel to line EH. What's the conclusion of that? Well, we want to use that to show that right. So if the line EH is parallel to GD, then this angle will also be 20 degrees because it will equal this angle. So there are corresponding angles, in fact, with this transversal AE. So the angle FEH, based on this parallelism, would equal the angle BAC equals 20 degrees. So this is 20 degrees. And remember that this angle is also 20 degrees. This purple angle here is also 20 degrees. And so the quadrilateral FEDH is inscribed. So that's 20. Also, the angle FDH is 20 degrees. And so the quadrilateral EDHF is inscribed, which gives us this angle here, angle HED, equal to this angle, DFH. Well, we know that's 20. The same way that this was 20, we showed that the angle FDH is 20. The same way we can see that the angle DFH is 20 degrees. So this is 20 degrees. Together they make 40 degrees. So the angle, what you're looking for was the angle BED. Angle BED equals 40 degrees.